Okay, so I want to start today with a piece of hardware that, usually gets absolutely zero respect.
The thing you kick under the desk.
Exactly. The thing you jam behind a cabinet. We're talking about a cable.
Usually the last line item on the budget and the first thing to fail.
But this
Yeah.
is not your average cable.
Mm.
We are looking at the Kramer CLS-AOCDP-UF-262. And we have to address the elephant in the room immediately.
Oh, yeah.
The MSRP on this single cable is $930.
It's a serious investment.
Serious is an understatement.
Yeah.
Even with a discount, you're looking at over $700 for a wire.
Mm-hmm.
And my first question is this just marketing, or is there actually, $1,000 of engineering inside this thing?
It's definitely the latter. But to understand the price, you have to look at what it does. This specific unit is 80 meters long.
80 meters. That's, what, 262 feet?
Yep. The length of a football field, basically.
Look, but why can't I just buy a spool of Cat 6 or some long copper HDMI cable for a fraction of that? Just, string it all together.
You could try, but you'd just get a black screen. It's a physics problem, really.
A physics problem.
Yeah. We aren't just sending a simple signal anymore. We're talking about DisplayPort 1.4. That needs the bandwidth for 8K resolution at 60 hertz.
I'm looking at the spec sheet, and it says the data rate is 32.4 gigabits per second.
That's HDR3, high bitrate 3, and when you try to push that much data through standard copper for 80 meters, the electrical resistance just destroys the signal.
It just fades out.
It's called attenuation. All the high-frequency data, the actual detail in your image, it just turns into noise before it even reaches the screen.
So Kramer has to get around that resistance problem somehow.
By switching the medium entirely, this is an active optical cable.
Oh.
An AOC.
It's a hybrid, right?
Exactly. It's a hybrid architecture. Inside, it uses 4 multi-mode optical fibers to transmit the video data with light.
So photons instead of electrons.
With the heavy lifting, yeah. But they also run 8 copper wires right alongside the fiber. That's for the lower bandwidth stuff, the handshake signals, power, control data.
The thing that usually bugs me about active cables is the power penalty.
Mm-hmm.
You're always stuck looking for a USB port to plug in a little pigtail, or even worse, a wall wart power supply.
Which is a complete nightmare for installers. If you're running this through a ceiling, the last thing you want is a bulky power brick.
Right. But I'm looking at the manual here, and I don't see any external power inputs on this thing.
And then that's the real engineering flex. They've managed to get the power consumption of the lasers and the chips down to less than 500 milliwatts.
Half a watt.
Just half a watt. It creates this plug-and-play experience so it feels like a passive cable, but under the hood it's sipping just enough power from the DisplayPort connector itself to drive a whole laser engine.
It solves the distance problem without creating an installation problem.
Exactly.
Speaking of installation, let's talk about where this is used. You aren't running an 80-meter cable in a living room.
No, absolutely not. This is going into a ceiling, plenum space, or maybe connecting a server room to a display in a huge lecture hall.
Which means the physical build requirements must be totally different.
Completely. You need something that won't snap when you pull it, and something that won't be a hazard if there's a fire.
The specs say it has a pull-on strength of 25 kilograms. That's over 50 pounds of tension.
It's robust, yeah, but the jacket rating is even more critical. It's low smoke and halogen-free LSHF.
And why is that so important compared to, say, a standard PVC jacket?
Well, if standard PVC burns, it releases thick, black smoke and halogen gases.
Nasty stuff.
Very nasty. It can turn into hydrochloric acid in your lungs. In a hospital or a public building, that's incredibly dangerous. This cable is compliant with safety standards, which means it's safe for permanent installation inside walls.
So it seems like we need to reframe how we even think about this. This isn't really a cable in the traditional sense.
I think that's a great way to put it.
It's more like a piece of active electronics that just happens to be shaped like a very long wire.
Precisely. It's a precision component bridging a gap. It's handling 8K, 3D, 8 channels of uncompressed audio. It's doing a lot of work.
Which brings us to the future of all this. If we're already using optical fibers and laser diodes just to get 8K across a building.
The writing is on the wall for copper, at least for long runs.
Right. So here's the thought I want to leave you with. When 16K becomes the standard, or when refresh rates double again, will copper wire just disappear entirely from high-end video?
We might be looking at the last generation where copper is even part of the conversation. The future is almost certainly optical.
Something to keep in mind. Well, that's it for this deep dive. Thanks for listening.